Judy Warner. Welcome back to this week's Ecosystem Podcast. Today, I'm joined by Steve Sandler of Picotest. As you know, he's one of the world's leading experts on power integrity, and he's just returning from a whirlwind tour across Europe for a couple conference. And he's going to talk to you about things you need to be thinking about as this unprecedented pace of innovation is coming at you and ways you continue to grow and get good information to help you be a better engineer. Now let's jump into our conversation with Steve Sandler. Hi, Steve. So good to see you, my friend. I guess it's time for our quarterly, half-yearly catch-up and find out what's going on in the world of Steve Sandler.
Yeah, I don't know which one it is, but I'm always happy to talk to you. I always have so much fun when we talk, and it just seems like we could keep talking forever and never run out. So I'm happy to be here.
Well, I'm ready for our Steve Sandler fix, and I know you just got back from a whirlwind tour of Europe with PCIM and another conference, which we'll talk about. But why don't you take a quick moment, introduce yourself for any poor soul who doesn't know who Steve Sandler is, and then let's talk about what's going on in the world of Steve Sandler and Picotest these days.
Sure. So I'm Steve Sandler. I'm the founder and managing director of Picotest, and we're a company that specializes in measurement instruments, measurement products, and mostly focused towards power integrity. These days, AI.
Yeah, so let's talk about that. In line of your travels and your papers and all the things you're doing, why don't you tell us a little bit about that and exactly the specific ways that AI is driving some of that from your client's perspective?
Sure. I mean, it really is interesting because these days I think that's really all anybody wants to hear me talk about is AI data center, AI data center. We see it everywhere. Um, but the whole idea of AI data center, whether you're talking about the AI, the data centers, HPCs, the supercomputing, whatever it is, they're all driving us to the same place. And that place that it's driving us is kind of incredible. It's a little bit scary, actually. I don't know how many times I said in the past week or two while I was in Europe that, depending on the day of the week, I either wake up saying, oh, thank God I'm not a young engineer right now. And the other half of the days, it's, man, I wish I was a young engineer right now because I'd have so much energy and enthusiasm for all of this. Um, but the bottom line is that it's really just pushing the state of technology and it's pushing it into places that I don't think anybody could ever imagined and at a pace that nobody's used to. And so I think, at least for me, and from what I hear from a lot of engineers that write to me or that I speak to, it's like, just how do we keep up? I
Right.
don't know. I don't know. I'm thinking just like you guys, just staying just a little ahead of you.
Yeah, the pace is it's definitely been a theme with people on our podcast is the unprecedented pace of innovation right now. And it had to take something, I suppose, like AI. And so, like you said, so many opportunities and so many challenges. So, why don't you tell us, like I said in the beginning, I know you just came back from PCIM. Why don't you tell us about the two conferences you came from, what your takeaways were, and maybe give our audience some insight to trends you're noticing and things that you sort of took away from these two shows you participated in?
Sure. So PCIM, it's a power conference. It's in Europe and it's held in Nuremberg every year. If you've ever been to Nuremberg, it's a great medieval city. I mean, it's beautiful to see it. Of course, by the 12th or 13th time, it's not quite as charming, but it's still a beautiful city. And we generally share a booth there with our sales partner, Omicron Lab, and so we did this year again, and that's always fun. We like each other. We do so much together, and so to get that FaceTime, in person time is really great. We haven't been in, I want to say probably 6 years. I think this is the first time we've attended in 6 years,
Oh,
partly because of COVID and partly because of
yes.
conflict. But this is the first time we've been back. And it was really interesting because so much changed. And I think that's probably the part you're interested in hearing about. It's a relatively big conference. It's bigger than DesignCon. It's bigger than APEC, smaller than Electronica, but a decent sized conference with maybe 20,000 people.
Uh-huh.
And so much of it this year was AI data center, but kind of hidden in different clothes. Nobody was saying AI data center, but there was so much cooling technologies. Everybody
Mm.
had high power cooling technologies, water cooling technologies, gas vapor cooling technologies. Somebody suggested that we put air conditioning refrigerant in our probes to help keep them cool. And I said, what? Um, so one thing that I noticed is that the things that I'm seeing and hearing are just so far out there. Um, and I noticed this when I was at APEC too. I got invited to a roadmap meeting. And so it was me and a bunch of people like me from different companies and industries talking about what do we see coming. And I made the comment that, power supplies for as long as I know have been controlled by PID controllers, portion, integration, and derivative. And that seems like it ran out of steam. Maybe we need to think about something more advanced. Maybe we need to think about something like state vector. And two people in this meeting from two different companies said, we're doing neural network feedback. And I said, what?
What?
And they said, well, we're using AI to actually control the feedback of the power supply. And what we do is try to predict what's going to happen next as a result of the computer workflow so that we can have the power supply respond before it happens. And I shook my head and I wondered, am I really here? Um, am I dreaming? Um, what?
That's wild.
Um, this doesn't make sense. And so we're seeing things like that. And you listen to it over and over again. And finally, you realize that you're part of this conversation. And all of a sudden, it's become normalized. And we
Which
all
is
talked about,
absolutely science
yeah,
fiction, right? We're
it
living
is. It
in
is science fiction. And people are talking about how did we get here? And
and get
how do
here so
we,
fast.
I think that's probably the biggest challenge for people is how fast it's moving. But here's what happens, I think, and my theory on it is that there was a lot of money behind AI, and people chase
You
money.
bet.
And as soon as they started chasing the money, money got even bigger. And then every major company, the Metas, the Googles, everybody started working AI. And then we hear about the government's Stargate, $500 billion. And all of a sudden, we're sitting here talking about trillions of dollars,
Right.
trillions. And these smart people in these companies, the one thing that they know is when people are talking about $1 trillion, grab the money really, really fast because somebody's going to throw up a flag saying, whoa, slow down. We can't afford this anymore. So grab
Right.
as much as you can, as fast as you can. And that, in part, I think is responsible for the crazy level of acceleration. But anyway, so while I was at PCIM, we saw a lot of this, fringe kind of stuff. And um, mostly component technologies and cooling and so on and so forth. And then when I left there, I got to spend a few days in Rome while I waited for the SPI conference, which is an IEEE conference. And it just happened to be in Italy when they announced the new Pope. So you can imagine how crowded Rome was and how many people were, trying to see everything related to the Pope. In fact, the word Pope was everywhere. Of course, it was also interesting that he was an American, first
So
American politician.
interesting. I was going to
So,
ask you what's the response, sort of you were feet on the ground. What was the response?
you
Or
know,
what
um, most people didn't even realize that he was an American.
mm,
Um, the ones that did, I don't think there was much that cared. There was a lot of talk about the fact that he's so young, and so there's going to
mm,
be around a long time. Um, but also people realize this is a crazy moment in time that we don't normally get to see. And so I don't know if you watched the movie. There was actually a movie about,
I
you
did
know,
Conclave.
yeah, great movie. I loved it because I love Stanley
I
Tucci.
liked it too. Yes, I love Stanley Tucci and it was a great cast, but from what I understand, most Catholics didn't like it.
That could very well be.
Yeah.
But anyway, I know that movie has now surged. because everybody wants to see it, and nobody knows what actually happens. So it's anybody's guess. But it was an interesting time to be there, and it also coincided with the 25-year jubilee, which occurs in Rome every 25 years, and this was the year. So it was. I mean, it's always great to see Rome, but boy, was it crowded. Then we went on to SPI, which is an IEEE conference, and it moves countries every 2 years.
What does
And,
SPI stand for?
um,
You know?
Signal and Power Integrity, I think it is.
Okay.
There's so many IEEE conferences that now
I
have
know.
SPI in them. There's EMI plus SPI, EMC SPI. There's so many. But this one I've been to a few times. I've lectured there a few times. Um, it's an interesting conference because it's small, very academically oriented, and it's in each country for 2 years. So for 2 years, it's in Italy. This was the first time. It was in Gaeta, and it was really fascinating because they actually held the conference in a castle, which is really cool. Um,
That's very cool.
yeah, beautiful little peninsula, the castle on top of the hill, and we have the conference inside this castle, which sounds really great. But castles are on top of hills, and you got to get up to the top of the hill.
Ah,
That wasn't nearly as
yeah.
much fun. And it's not very far. It's just uphill. So trying to find a taxi that's willing to just drive you up the hill can be a challenge. But it was beautiful, very small, academically focused conference on SIPI. And it was interesting because I saw a lot of people there that I know, that I've seen over the years, but not recently. In fact, even the engineers from Mayo Clinic, Jordan Kuzman
Mm,
was there. He gave a
mm.
paper. In fact, he gave a paper before I did. And Nicola Femi, a professor, I lectured for his classes before in Salerno, Italy. So I got to see him, and it was really, really great. But it's a great place to talk about academically focused power integrity. And so I did that. Um, and it was just good. And then we got to go back to Rome for a couple more days on my way home. And now I get the job of overcoming jet lag. And I wish I could make an Arduino program or something that you just push the button and the jet lag goes away. So if you ask me, any pet projects, that'd be a good one.
Yeah, that'd be a really good one. So you just got a very interesting bit of exposure, right? You were in 2 different countries, of course, all in Europe, seeing both the academic and the industry side, AI, but not it's AI data center, but then there's this whole ecosystem, right, that's building up around this thing. So I think my curiosity with you is how this is gonna affect the engineers in our audience. Like, of course, thermal, is a biggie, and I think that's just gonna continue to go on. Um, you know, what else are engineers in our audience going to see, or how can they be proactive about maybe upskilling or, being thoughtful about sort of where the industry is going? And so that's part A. Part B is, what is the difference in the conversation between academics and industry? And are those converging in a positive way?
See, that's why I love talking to you because you get the best questions. That part B actually came up while I was in Italy, and so I can talk to that a little bit just based on what the professors were saying, and also what some of us, that are not academically focused were saying. So I can talk about that. Um, but interestingly, we are putting a lot of pressure on engineers right now, a lot, and in two different facets. On the one hand, they have so many more things to do than they ever had to do before, and that's a challenge. Just by itself, it's a challenge. But now we're asking them to do it faster. And one of the things that I've been talking about a lot, maybe for the last year, maybe even a little bit more than that, is that when we develop new technologies and work on these new cool things, if we can't scale it for at least 3 years, it's a waste of money.
You
We
bet.
have to be able to scale in 3 years. And right now, technologies are not able to do that. None of them are. And as a result, I think that means a lot of people are dumping a lot of money into stuff that never gets recovered, and that's a challenge, a real
Is
challenge.
that because the technology isn't there, or is it because the ecosystem hasn't grown up around it, or both?
This is just my opinion, but I think it's because we're not able to reach far enough. We think, "Oh, I know where we're gonna be in 3 years, so
Mm.
we're gonna design with that as our target." And 6 months later, here we are, we're already past that. Um,
Yeah,
and I think part of it is just that we're not capable at this moment of thinking, "Where will we actually be in 3 years, and how will we get there?" And this is part of what challenges engineers. So when I talk to young engineers, they want to know, what do I do to prepare for this? How do I,
exactly.
make my mark? And what I would tell you is there's so much happening in so many different arenas, whether you want to talk about materials, graphene. My good friend Mark Browan from Thin Film Technologies, he's always talking about graphene. And yeah, there's just so much interest in that. I hear from component manufacturers, people that make capacitors and resistors and whatever, and everybody's looking for how do we make a big change that results in much better performance. Printed circuit board materials, new laminates, whatever it is you want to talk about. And then we develop these things and it puts pressure on us from thermal standpoints and it puts pressure on us from simulation and modeling standpoints. One of the things that I talked about that's really challenging, and I've said, I think more than once, probably even when I talked to you, that this is the third time in my career that I've been in a place that nothing made sense and everything I knew kind of evaporated. And I
Mm.
remember the first time in 1978, I had mastered the use of bipolar junction transistors. We knew everything about them, and Alex Liddell came along, gave us MOSFETs, and screwed up everything. We knew nothing about MOSFETs other than that they were cool. And then we never saw bipolar junction transistors again. And I had all of this knowledge about how to maximize the performance and whatever that nobody needed it, nobody wanted to know it. And so I think we're kind of in that space again where we're getting to this point that the things that we do know aren't helpful. And it's actually what I presented at SPI was that, we've learned everything about impedance and target impedance, and I've lectured on road waves and stability-based impedance and all of that. Um, and they all have fundamental criteria, and that is that for them to work, our solutions need to be uh, time independent and linear. Today's technologies are neither. And so we're still trying to apply these technologies that just don't fit, and we don't have replacements. And so,
Right.
the end of my paper, I left my conclusions page blank. And I said, because I don't know what the conclusion is. The conclusion is I was able to find all of these faults that we can't support. I was able to get beautiful pictures of large signal impedance. What I can't tell you is what it means, how it matters, and how we use that as a design tool. That's still to come. And so that's kind of scary that here we are racing ahead and we don't even have the tools for it. So this kind of comes back to, so what do engineers need to do? I think they need to be so proactive in absorbing material. They need to be those sponges they were when they were, young and ambitious. They need to read
Uh-huh.
everything they can find. They need to be following things they're not interested or involved in. Material sciences, printed circuit boards. I don't know how many times in the last year I said, I really wish I hadn't slept through my EM classes in school. But I was saying, I'm going to be an electrical engineer. What the hell would I ever do with EM? And flash forward 50 years, man, I wish I didn't sleep through those classes, right? And so I would say everything matters. And so pay attention to those things and pay more attention at the system level. What
Yes.
um, myself, what I'm always focused on is not what am I going to work on now, but what's in our way. If I can figure out what's in our way, then what I really need to do is figure out how do I move it out of the way? And we keep doing that one step at a time. It's like an onion. Every time you peel a layer, there's another layer behind it. But we just keep finding what's in the way and we move it out of the way. And this is where we get to your part B. So the academic world, they're really focused on high level academics. I mean, they're think tanks, they're geniuses, the
Research. Yeah.
mathematics of it. They're going to be the ones that figure out how do we make sense out of nonlinear time variant solutions. Eventually, they'll come up with that. Whereas in industry, we're focused on products. We need to get out products. We need to make money. And this is the ultimate divide. So one of the professors asked the question, how do we get industry and academic people to work closer together?
This is the question for the ages.
Yeah,
Like,
that's not possible, really. I do work with universities. If you do my, IEEE searches, you'll see I do a lot of work with universities, but it's very limited in what I do. It's they need help with a measurement or they need help understanding something or something like that. But on a bigger scale, it's really hard for me to work with them. The reason is we have such different goals. Their goal is to publish stuff and give it away. Our goal is to make money. We can't do
right.
both at the same time. And so
Mm,
never the twain shall meet. And so I think what happens is that there is an interaction between people like me and universities, but we can't get it below a surface level because I'm
yeah.
interested in tapping their knowledge without telling them what I'm doing. And they're interested in trying to learn what I'm doing without giving away their publications because that's their focus is their publications.
Right.
And because we have such divergent goals, it's really hard for us to work together. And so where I am working with the academic world more than ever is in things that I'm now willing to publish because I think I've used up their commercial value. For example, our non-invasive stability
Mhm.
measurement, which I think I developed that 12 or 13 years ago, and we would never publish that math. We did actually publish it with the University of Cambridge, and I don't think it's out yet, but we did actually publish that. We are publishing my SEPIA transient domain solution because we kind of feel like we got the value that we needed to get
Right.
from it. And now there's a big value in sharing it, but that big value in sharing, it's not money. It's I can
Right.
feel good about myself, right? And I can feel like I contributed back to
Right.
this community that helped me. And so I think that's really the challenge. But one thing I'll tell you is that in every paper that I listened to at SPI, they all talked about the limitations of SPICE. They all talked about the impacts of printed circuit boards in performance. They all talked about temperature issues and related to printed circuit boards. And so I kind of think that engineers today need to be really focused on that. I
It's
say
where
we
all
need
the
to be able to scale.
problems it's where
Yeah,
all it well, I mean, from not from experience, but it's this, PCBs, even in their most modern iteration, is still old technology. And
it is. But we
so
are putting new twists on it. Like, I'm just starting to read now about graphene coated printed circuit board materials and
mhm,
the benefits of graphene in high speed signals, the benefits of graphene in DC performance. And so we are starting to look at ways that we can make improvements. But you're right,
mhm,
in general, it's an old technology. The problem is that for us to be able to scale and optimize our performance and to keep this exponential growth we're at, we
right,
need to be able to do this at a system level ecosystem. And that means that everybody's contributing to an end to end model, which Heidi and I have been promoting for a decade now, right? But
right.
engineers are still clinging to their Spice and Simplest and LT Spice and whatever. Every professor gave papers on why it is that that's hurting us.
Hmm. Yeah, engineers, we love their tools. They don't give them up easy, which I understand. I think I would be absolutely that way, you know what works or how to wield a tool, and to, like, start all over is no fun, um, but I think it demands it. Do you think AI is going to have disruptive capability inside the way we create hardware, maybe in PCBs?
I don't think so. I mean, there's a lot of schools of thought on it, and I can only give you
Yeah.
my opinion. I know
Yeah.
that my grandson is thinking about being an engineer, and he asked me the same question. What do I do that doesn't get overrun by AI by the time I graduate? Um, I think AI is just going to be a tool like any other tool. One of the things that I just recently did is I picked up photography as a hobby again.
Hmm.
And when I was young, it was a great hobby. I had a color dark room. I was really into photography, and I hadn't done it for 30 or 40 years. And so I picked it up again. One of the things that I noticed is that everybody has software tools for fixing your photographs. I can change your face. I can change the fact that your eyes were closed. I can make them open. I can make you smiling even though you aren't smiling. And all these capabilities, everybody has it. And they're relatively inexpensive, but it didn't get rid of photographers. It just gave photographers another tool. And what it
Right.
did, I think, is it raised the bar on the expectations of what it is that we can do. Um, and that's both good and bad, right? We don't have to worry about taking a good picture anymore because we could fix it in AI. It's okay that it's out of focus. AI is going to fix it. And I think that there's a part of that we have to be careful that we don't become lazy because there are these tools that are going to be able to fix it. So I think there's that. But I also think that what it's going to do is it's going to put a lot more information at our fingertips that's going to make it easier for us to do what we do so that we can focus on the hard stuff and let AI
Hmm.
focus on the basics.
Yeah, I heard the saying, and my listeners will know I've said it a couple times because I liked it. At least for the short term, somebody said AI isn't coming for your job, it's coming for your tasks, right? So, at least right now, AI seems like an assistive tool and a co-pilot, but the intelligence and engineering judgment still needs to live with the engineer. And I think that's true at least for now, but there's sure a lot of people taking whacks at it, in a million different ways. I was just curious of what your opinion was. Um, and I do agree with you. Actually, I'm doing a podcast later this week with some folks at Samtech are talking about glass core. So I think there will be things, materials, particularly maybe fiber optics. Who knows? But
Yeah.
uh,
One thing that's difficult is that, AI scours the internet to capture information, right? That's large language modeling. But there's so much bad information out there, and it learns that too. And I just saw an example of this. I was trying to figure out how to do this calibration on my Keysight E5061B, and I looked it up, and I got this great AI response that told me exactly how to do it. And I just couldn't make it work. So I sent it to Keysight. Keysight laughed and said, "Sounds good, but our instrument doesn't do that." And all right, so AI doesn't know that, and I don't know how. I mean, we can't correct the disinformation that's in our social media, right?
right.
How will we do it in a large language model? That'll be really hard.
Well, I think we're going to see more and more engineers moving or companies, engineering teams moving those LLMs and those servers and making them on premise where they can scour and only put in known good data. And I think that's the way they're going to protect their IP. At least that's kind of what I'm hearing. And
I can tell you, we are actually exploring that ourselves with local AI that can scour our own intranet.
yes.
Even just for things like organizing and finding my own papers. I have so many papers and lectures and presentations. I can never find the one that I want. But we are actually testing AI to see if it can do that. And, to say, hey, find me the paper where I talked about.
Mm-hmm.
Um, and it's doing actually pretty well at that. So we'll see how that holds up.
Yep. These are interesting times. So, Steve, I know you said you wish you were a young engineer again, but you're glad you're not. What are some practical tips? You talked about self-education. I think that's a brilliant thing to recommend. Where would you recommend people go get some of those resources so they are I mean, something we try to do at the ecosystem is stuff that we put on our platform, we try to put known good, solid stuff there so we don't add. I blame the marketers, even though I am one, right? We went for clickbait instead of accuracy as marketers, and that just polluted the internet. So the stuff that gets most ranked, and that's a nightmare for engineers who are out there Googling or doing YouTube. Like, that's a nightmare. So what would you recommend? What are sources um, where they can, of course, I know you write for a Signal Integrity Journal, and that's a peer-reviewed journal, so I know that's one good place. Where else would you recommend engineers go?
Yeah, I think Signal Integrity Journal is good. I think, conferences in general are good, but it's really easy to overdo them. So, I think you have to pick a conference that's kind of your place, maybe 2 conferences, because it could become really overwhelming really quickly. You just need to find one that you fit in. And for me, I was at so many conferences before I realized that DesignCon was my place. EDICon was close, but DesignCon was my place. And that's a place where you can learn from people that are in your discipline. One thing I always believed in, and this is probably true, even back when I was an engineering manager 40 years ago, I always liked putting old guys and young guys together. And so what I tell young people is find an old guy, a really
Yep.
old guy, because he's got a lot of wisdom. He doesn't have the energy you have. He's not interested in the grunt work because he's past all that, but he's got a lot of wisdom. And if you take the wisdom from the old guy and the piss and vinegar of the young guy and put them together, magic happens.
I
Um,
totally agree. That's my
Yeah, not only just
wheelhouse.
magic in that there's this transference, but, I always said that I want engineers to start where I ended, not where I started. So if I
Right.
don't convey all the things that I've learned to somebody before I stop, then I didn't really pass the baton. They just start over. And so that's what I tell young people is find an old guy that's doing the stuff that you're interested in and stick with him.
As Eric says, I already made the mistakes, so just start there. Like, I already made the mistakes for you, so you don't have to, you know?
That's I like that. I might borrow that. I like
I
that
know,
one.
it was a good one. That's why I just borrowed it, so feel free. Um, there is wisdom, but it's hard won wisdom, and if somebody can help you, um, get past that, I think it's a good idea. It's also counterproductive because I think young engineers that they're digital natives, they grew up getting all their information online, right? And so I think that's a good encouragement, and I would echo that with you, is that, network and do shows. Now, not everybody can get budget to go to shows, um, but even if your company doesn't, I would go find that money, because it will it'll be money you invest in that will pay dividends for years.
Yeah, they do have a lot of programs, especially for the young people. Like Design Kind has 40 under 40, where they pay the
Mhm.
waiver of 40 young engineers that, wouldn't be able to come up with the money otherwise. And there's grants. And I've even helped people get to DesignCon because I think it's really important. Somebody did write to me recently, said, in the old days, it was actually before my time, but they said you used to be able to buy the proceedings from DesignCon.
I know.
And that's before my time. I wasn't aware of that, but they said that'd be really great because it's so much less expensive than the travel, which my company won't pay for, but I still
Uh-huh.
like to keep up and I'd love to read the papers.
Yeah.
Um, and I mean, you follow people on LinkedIn that you like. Follow me, and everything that I think is worth talking about, I put on LinkedIn. Every new thing that we're doing is there. So, um, I think that a couple of things. One is that I think that engineers don't read as much as they used to, and I think that's not really a necessarily a criticism. I think they're also busier than they ever were, but it's really easy to get left behind if you don't keep up. And so somehow, however you do it, you need to figure out how to keep up. The second thing that I tell young people is what they're missing is intuition. And I saw a T-shirt and I sent it to my daughter, but I think I'm going to buy one for myself. It says "classically trained." It's got a slide rule on it. I still have my slide rules here, but we just had this intuition for numbers. We did the napkin math in our head, and now we're so used to doing things to, 12 decimal places on a computer that, if we didn't see it in a computer, we just don't know. And I see this constantly when I'm reviewing reports or documents, especially from young engineers, and they calculated the voltage regulation is 1 femtovolt. Have you ever seen a femtovolt? Do you know what it would take to measure a femtovolt? The one thing I can guarantee you is it's not a femtovolt. I don't know what it is, but I can guarantee it's not that. But they just don't have that intuition. So I tell young people to try to figure out how to get that back. Just whether it's just doing napkin math or, practicing doing these numbers in your head to see if you can at least get close. There's a huge value in that. Not only in, designing and figuring out what the right answer is, but we just talked about how much bad information the AI is capturing, right? And we see that everywhere. So the question is, when I see something, how do I know whether it's reasonable or not reasonable
Right.
intuition? And that's getting worse with AI, by the way. We can see these videos, I watched Trump and Biden playing golf together. Um,
I
and
know, it's crazy.
there's no way to tell what's real and what's not. So if you can get that intuition in your belly, that's the way to do it.
I think that's a good encouragement to Steve, and of course, it reminds me of Eric's, rule number 9, right? Anticipate what you're gonna measure because in the digital age, it's so easy just to push buttons and you will get a number. But how do you know that you're even close or in the neighborhood? And that is I agree with you, the cross-generational, mixing, um, and again, something I try to create in a digital way on the ecosystem is to put the old guys and the new guys all together so they have a place to interact with each other and also on this podcast because we don't wanna lose that wisdom and that intuition because then we're at risk of losing decades of engineering wisdom. The foundational stuff that makes your antenna go off and go, "Wait a second," instead of just, "It gave me an answer, must be good." Like,
Yeah, we'll
well,
write that
how do
one
you
down.
know?
Yeah, we'll write that one down. And well, I mentor a lot of young people too. I actually enjoy doing that. So young people that are willing to do the work and willing to mentor them. I'm not willing to mentor lazy people, but people that really are willing to do the work. I'm happy to be their mentor for the same reason. I want them to be able to start where I ended, and I want them to get used to thinking in this way where we can get rid of all the garbage and focus on the signal and not the noise.
Well, that's a good place, I think, a good segue for us to wrap. Steve, I know you have, of course, as you mentioned, people connect with you on LinkedIn or maybe see you at DesignCon or other shows, but I know you have some tremendous online training um, content. Can you tell our listeners a little bit about that? Maybe they want to tap in there.
Yeah, that's true. So, so much of what we do as engineers is focused on measurements. And one thing that we're not really taught in school is how to make good measurements. So, we made a class that was focused on making accurate measurements. And we used to do it before the pandemic. We did it as a hands-on workshop, which was difficult. We couldn't get that many students in, and we had to ship equipment all over the country to do it. But we did that as a hands-on workshop. And because of the pandemic, we actually recreated that as an online class. And it covers everything that engineers need to know about how to make accurate measurements, and most of it's not hard. I mean, there's a lot of tips, there's a lot of things to look for, and a lot of, simple steps that you can do to make your measurements better. But we made this class, and if you're really interested in doing it along with us, we have the demo boards, and you can buy the demo board, and you can make the
Huh.
measurements go. You can even borrow the equipment from us, and we'll lend it to you, and you can start like that. But I think so much of what we do is based on measurements. And just like the AI, there's so many bad measurements out there. I know you've heard so many of my papers where I talk about why we don't use vendor measurements and insist on making our own. But it's
Right.
just because we need them to be accurate. At the end of the day, we need them to agree with our simulations. We hear so many engineers say, "Oh, my simulations and my measurements don't agree. Simulations aren't any good." It's not the simulations that aren't good. It's the models that aren't good. And where did those come from? And so I think the basis of everything that we do is in making the measurement. And so we do have an online class, and you can find it at picotestonline.com.
Okay. I'll make sure I put that in the show notes for you guys and gals that are listening. Steve, is there any place else we can plug our listeners in to learn more about Picotest and your probes and your
Visit
measurement
the
equipment?
Picotest Solutions page. The Picotest Solutions page is where we put the things that we do to help customers. I mean, we're so customer driven. Customers come to us and say, "Hey, we have a problem. Can you fix our problem?" And we help them, and then it goes on the solutions page so that people can find it and hopefully get the same benefit. We're constantly doing that. We make new products all year long, and it's really just because customers say, we need to measure this. How do we do it? We need to do this better. How do we do it? And I give them credit because at least they're working really hard to try to get where it is that they need to go. So people that are willing to do that, I'm willing to help. The ones that I don't like are the lazy ones that just tell me they just want the answer. Can you just tell me what the answer is?
Right.
That I just don't have much of a patience for.
Well, that impatient is hard won over many decades, and if you're going to invest your valuable time and resource, it only makes sense that you invest in people that are willing to invest themselves. Steve, thank you so much for this update and sharing with us everything you've been up to and your European tour and your training materials. And let's do this again in a few months. I can't ever keep up with you, but it's always a joy to reconnect and hear about all the exciting work they're doing.
Yeah, you bet. It's always fun. And believe it or not, we're already getting ready for DesignCon. So here we go again.
That's crazy. May. When is
Yeah,
it this year? February?
February, February,
February.
February 2026. We're already
Okay.
working on papers for it. So here we go again.
By the way, for our listeners, if you didn't see it online, DesignCon just opened their call for papers. So if that's something you think you might want to get involved in, I know many a fine engineer that was a real pivoting point, is to present a paper or to attend one of these papers at DesignCon. So I'll put the link also for the call to papers in DesignCon because that'd be a great way for you to again invest in your own career.
Yeah, it's
Well,
again a great point. It is a
yeah.
great point. Then I am a first-time author's mentor also. So if somebody wants
Oh,
to run a paper, I am a mentor for that.
okay, great. Well, Steve, thanks again. I will let you go. I know you're still jet lagged, so I appreciate you coming on while you're still recovering from
Oh, you
your.
bet.
Thank you again for joining us today. Make sure you go check out all the links in the show notes. We'll see you next week. Until then, remember to always stay connected to the ecosystem.